Is that clear? Can I erase? Now, first we'll see the future selection techniques followed by future extraction techniques. Both of them separately. First, let us start with future selection techniques, out of which what is meant by future selection techniques means simply drop them. Simply drop them. Okay, if it is unimportant variable means identify the unimportant variables and dropping them is called as future selection technique. Right? Now, in this we are having three types of methods are there. One is called as filter method. The second one is called as wrapper method. Third one is called as embedded method. Okay. First one is called as filter method, wrapper method, and embedded method. These are the three different methods which we are having. Right? Now, in that filter methods, what is meant by filter methods? Just by applying the filter. What is meant by filter? In pandas, what is meant by filters? I have told you. Writing the conditions. Just by writing the conditions, you are going to identify the data and you are going to extract the data. Now, filter methods means same thing. Just by writing the condition. Just by writing the condition, whichever the condition not met, that data you are going to remove. Here for continuous variable, we are going to see low correlation value. Correlation coefficient means, for example, if it is having the output and input variables are not having any correlation, very low correlation is there. Low correlation coefficient, we are just dropping them. We are going to drop the whichever the futures are having low correlation coefficient values. That is number one. I told you, if you want to drop more than 5%, you have to statistically prove. Less than 5% means you as per your choice, own choice. If you want to drop more than 5% of the data, statistically you have to prove, means you are proving that there is no correlation between them. This is statistics only, right? Correlation is statistics technique. In the descriptive statistics we have discussed. So now correlation says about the relation between two variables. The two variables are, one is input variable, one is output variable. There is no relation on one of them. Then what is the use of others? For example, you take you are in this class. Okay. I am the output variable and you are the input variables. And now there is a relation between you and me is okay. Very good correlation we required. You and Naresh IT, very good correlation is required. With respect to you and with other faculty, like full stack or AWS faculty or Azure faculty or some other faculties will be there, right? In the Naresh IT, what is the relation between you and that faculty miss? There is no use. For you, whether that faculty is available also, there is no use. If he is not available also, no use. For you, only SRK is important. At the same time, Naresh IT is important because at the end, they have to show you the placement opportunities. I have to train you and they have to show the placement. These two are important. Remaining everything is unimportant to you. In this, how many batches are there unimportant to you? Which time of batches are there? Who is cancelling the sessions is unimportant. Nothing is important for you. So which is not important for you, just you are going to ignore that one. You are not going to maintain the entire Naresh IT, right? So to know that, oh, this batch was cancelled. Oh, 11 a.m. batch cancelled. Morning 7 a.m. batch cancelled. That trainer is doing like this. This trainer is doing like this. Who wants all these things? We are learning the subject, and based on the subject, are we getting the job? And if we get the job and we are getting a good package and a good career, that is important for us. Okay. What about the others? We don't care. Unless we get an information and we want our presence is there in that means, then we require. Otherwise, we don't care. Now, here the correlation coefficient. Now, generally, if I say that I am working in Naresh IT means, they say that, oh, this faculty is there, is Simchna, his batch, when it is the batch means, who knows? If I am working in the Naresh IT means, it is mandatory that I should know all the faculty names and what are the batch timings means. Never I know that in the Naresh IT, I know who is the teaching faculty means, only 2 faculty I know till now. Who I have met is only, and until now in my career, only 2 in entire Naresh IT. Because there is no use for me to meet others. Okay. So now coming to this correlation coefficient, which is having a low correlation coefficient, just you are going to drop. And second one is variance, low variance. For example, a particular future is having 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Completely 1 only is there. If that column is there, also 1 only. If the column is not there, also 1 only. The column not there also the same answer. Now it is not going to affect. If any particular column is having low variance, you can drop that one. Low correlation coefficient drop, low variance drop, which is having a very low variance drop, because there is no use of that column. If very high variance is there, then we can understand, oh, this much of variance is there based on this. Okay, we have to understand. If the variance itself not there, then what is the use of that? Now, sir, how we can understand? Can you explain with an example? Let us take X and Y. 1, 2, 3, 4, 5. Okay. This one is 6, 7, 8, 9, 10. Now I want to identify the relation between X and Y. Y is equal to X plus 5 is the equation. Okay. Now let us assume there is one more column called as X1. X1 and X2 like this. Now earlier I have got only X2 plus 5. Now here 1, 1, 1, 1, 1, 1 is there. Now I want to identify the relation. What would be the relation means Y is equal to still X2 and X1, and I want to identify with respect to this one means I don't bother this one. Still the relation will stands the same. Though it is there also, still the relation is same. I'll get 100% accuracy with the above equation. No need of even X1 also. I don't need to identify the relation between Y versus X1 and X2. If I identify Y versus X1 and X2 also, and Y versus X2 also, still I will get the 100% accuracy. Right? For example, if I identify the relation between Y and X1 with X1 plus X2 plus 4, in this case also 100% accuracy, in this case also 100% accuracy. Two equations are there. If you observe the linear regression, take the same data set, apply the linear regression, you will get the answer like this, where the intercept value and quotient 1 and quotient 2 values, and R square is going to be 100%. Okay, just apply the linear regression. Now drop this column and still apply the linear regression. Once again, the same answer. Same answer means what it is saying that this particular column is not having any impact. Why it is not having any impact? Because there is no variance. Why there is no variance? If you calculate the variance of this, the variance is going to be 0 for this. The variance is 0, literally 0. Since there is no variation, automatically it is not going to affect. Okay, that is the reason we are going to have with low variance. Okay, variance in terms of not bias variance trade-off. It is the variance of individual column. Variance of individual column. df dot describe. You are going to use the describe now. In the describe, you are going to get the count, mean value, standard deviation. First one will be the count. Next one will be the mean, followed by standard deviation, followed by minimum value, 25 percentile, 50 percentile, 75, and maximum value, right? These are the things which you observe in the describe. Out of which standard deviation is there now? If the standard deviation is low, automatically all the data points are very close to the mean value. There will be no difference. If the standard deviation is equal to 0 means literally all the data points are equal to 1 only, one value only, any one value. That may be 10, 10, 10, 10, 10, 10, 20, 20, 20, 20. In all the cases, the standard deviation is going to be 0. If the standard deviation says is equal to 0 means all the data points are one value only, which is nothing but mean value only. Mean value and other data points both are same. That is the meaning of that. Okay, so you are going to drop the low variance values. And the third one is mean absolute difference. Mean absolute difference means each data point minus its mean value. Mean absolute difference, which is having the low mean absolute difference, that you are going to drop, which is not having any impact. Mean absolute difference or variance both comes under the same category. Right? This is for continuous variable. Okay, correlation you can identify only for continuation variable. Variance you can identify for a continuation variable. Mean absolute deviation you can identify for continuation variable. Now, coming to this one, information gain, discrete variable. How we are going to drop that? We miss by using the information gain. Whichever the variable is having low information gain, that you drop. If there is no information from that particular variable, what is the use of that one? No information, drop. Calculate the information gain. How to calculate the information gain? Already I have told you in the decision tree. Right? Now, later on, apply third one is chi-square test. Chi-square test or one proportion test. For one column, if you are observing one proportion test, with one column, the second column, if you are keeping, and it is two proportion test. If multiple columns, means chi-square test. Right? This one also I have explained. Just apply that one. Right? Next one is wrapper methods. In the wrapper methods, we are having forward future elimination, backward future elimination, recursive future elimination. What is meant by forward future elimination? Just if you are having x1, x2, x3 and y variable. Let us assume we are having TV, radio and newspaper and sales. This is the data set. First to drop the TV column. Okay. Second, you drop this one also, followed by this one also. Like this, one by one, you drop one after one, and that is called as future elimination method. Forward future elimination. Forward future means elimination means eliminating one after one. Okay. Future means drop column. You are eliminating the columns in the forward direction, one after one. Backward future elimination means in the backward direction. Okay, first you are going to drop the newspaper, followed by radio, and finally you left out only with TV and sales. Right? Now, recursive future elimination. Recursive future elimination means subset of futures. Subset of futures. Subset of futures, and you are going to eliminate. These are called as wrapper methods. Generally will not go with this one. 99.99% will not go with this one. Okay. Third one is called as embedded methods. 99.9999% will go with this. Literally 100% will go with this. Before modeling filter methods, after modeling embedded methods. Before model itself, we want to drop some of the columns, means apply the filter methods. After the model, identify the important features from the model. Bagging technique, random forest gives you the model dot important features, right? What are the model is that? Model dot important future underscore importances. If you write like this, you are going to get in terms of important features. In that, whichever the features are having 0, okay, drop them. Okay, model dot important futures underscore importance and boosting also model underscore future importance. Identify them and drop them. Okay, embedded methods. This is called as embedded methods. Okay, now next one is lasso regression. If you observe this one, the same thing I have told you during the lasso regression. How many of you can remember? I don't know. Just I'm opening your drive. In the drive, I'll show you in terms of this regression. In the regression, while I'm explaining this regression technique, while applying the regression technique, I told this point. Lasso regression can be useful if we have several independent variables that are useless. And rigid regression can reduce the slope close to 0, not exactly 0. But whereas lasso regression can bring the slope exactly equal to 0. And I told that if the slope value is equal to 0, means that particular future is not important. Because slope is equal to 0 means y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. And out of which beta 2 is equal to 0 means what is the meaning of that? If this beta 2 is equal to 0, one of the slope is equal to 0, what is the meaning of that? This particular variable is you are not going to multiply. For predicting the output variable, you are not going to consider that particular variable. So lasso regression can bring the slope exactly equal to 0. So it identifies the useless variables. Is that clear? So these three, lasso regression, after applying the model, after applying the model of lasso, then you'll identify which betas, that is slopes, are equal to 0. Which slopes are 0. When you'll do after model only, before model, you can't say which one is unimportant for this. Which slope is going to be 0, you don't know before itself. After applying the model of lasso only, you'll understand. So these embedded methods means after applying the model identifies which are the important features, is called as embedded methods. Okay, embedded methods means identifying important features, identifying the important features after modeling. Identifying the important features after modeling. First, you have to apply the model, and from the model, identify the important features. After identifying the important features from the model, drop them and reapply the model. Clear? Okay. Step, identify the important features after modeling. After identifying, I'm writing even that. After identifying, drop the unimportant features or useless features. Drop the unimportant features and reapply the modeling. Reapply or redo the modeling. After dropping the unimportant features, now you'll have less amount of features. Now again, you do the modeling for the same algorithm, not for the different algorithm. After dropping, before dropping, okay, before identified the modeling. So first you will apply the modeling. First, what is the step you will do is modeling. After that, you will do the prediction. After that, you will do the evaluation. In the evaluation, you will identify it is 90%. Okay. Now you will identify the next step you are going to do is futures importance. You are going to identify important futures. These are the 4 steps which you are going to do. After identifying the future importance, again come back to modeling, again do the prediction, again do the evaluation. Now automatically evaluation value will be increased. Your accuracy will be increased. After dropping the unimportant features, now either accuracy will be increased or time will be reduced. Any one will happen, surely. Because earlier you have done with modeling of 95 features. If you remember in the data set, which is mushroom data set, in the mushroom data set, I have done with 95 features, input features initially. I identified only 15 features only important in the ADA boost or gradient boost or exit boost, only up to 15 features. 10 to 15 features are only important. Now these 15 features, again, if I apply means, obviously the computational time will reduce now. Earlier working of 95 features, now only 15 features means 80 features you are dropping means at least some time will be reduced, right? In fraction of seconds, okay, let us take in fraction of seconds, at least some seconds will be reduced now. So either time will be reduced or accuracy will increase. Anything will happen. Is that clear? So these are called as future selection techniques, out of which before modeling, what are the techniques we are going to apply is called as filter methods. After modeling, what are the techniques you are going to apply is called as embedded methods. Clear? That is with respect to future selection techniques. In the both future selection, in all the future selection techniques, the common thing is dropping the future. For example, in this class, I'm not interested on one of the student. Okay. Just a minute. Okay. If I'm not interested in one of the student in this class. Now, for example, I'm not interested in the first bench student. I will ask simply to him, can you please get out? Okay, I will ask simply to get out. And he will go off also. Okay, simply he will go off. Okay, whatever the reason, I'm simply asking to him get off. But he is having certain advantage. He is also having certain advantage. Let us let me explain in a different way. You are in a company. Okay, in a company we are having some members. Okay, for a particular project, we are in a company for a particular project. We are working, and in that project, their members are there. Assume that total 3, 6, 7 members are there. Okay, out of these 7 members, one member is very slow. He is very slow, and he's doing only just 2% or 3% of work. Remaining all of them are contributing 10 or 15% or 20% of work, but he's contributing just 5% of the work only. Okay, he's contributing out of the entire project 5% of the work. Okay, remaining 95% of the work was done by the 6 members. Now, what I want to do is I want to drop him. That is called as future selection technique. Means you are dropping the unimportant variable simply. But if you understand this, he is also doing at least 5%. Nah? Why we can't utilize that 5%? So he's having his advantage. What we are going to do is we are going to, before removing him, we'll ask to do the knowledge transfer to others. Whatever the knowledge he is having, we'll ask his knowledge to share to others. Now he has shared the knowledge to others. Now his knowledge is already with them. Whatever his work, others also will do, right? Now, other 6 members can do this 100% work. Now there is no use of this one. Now we will drop. Simply before dropping, first we will ask him to knowledge transfer. After that, we will drop. This is called as future extraction method. Okay, asking him to share the entire knowledge. Now he is not having anything with him. Now he is useless for us. Whatever he can do, we can do the same thing. Simply we will drop him. That is the reason in the industry, generally they will not share the knowledge to others. Okay, so if you ask also, they will see as a cheap way. If they ask also, we'll also see at them as a cheap way. In the IT industry, very few members will discuss among themselves. The few members are called as friends. Who will discuss among themselves are called as close friends. A normal friend also will not discuss with them. Very close friend, almost equal to family. With them only we'll discuss with respect to whatever the subject we are having, we'll share with them. Generally in IT industry. Okay, if you come with me, miss, for me no problem. For me no problem, because basically I'm a trainer now. If they ask me, generally I'll think as a student is asking some question, and I'll explain for them by default. Okay, I'll start explaining everything, and at the end, sir, now you'll ask me, sir, if you share your knowledge like this, automatically your value also will reduce now. But here, whatever the questions they are going to ask me, they are going to ask with low level. In the high level, whatever the questions they ask me and we will discuss now, at the end, there will be no use. They'll feel that importance of SRK is there. One day, if they find that there is no importance of SRK also, this company may not find. Multiple companies are there. If these people relieve me, miss, immediately I will get a new job with a better package only. Obviously, I'm having that confidence, so there is no problem for me. If I'm having the fear that, okay, these people leave me in the next company, whether I'll get the job or not, next 2 months, whether my family will survive or not. If this type of questions are there in my mind, miss, it is very difficult to sustain. Okay. And who are already working in the IT industry, they know all these things. Right? Simple. Similarly, here also in the data science, how we are going to do the knowledge transfer means nothing but we are going to apply the concept called as covariance. 2 variables are there. Variance of one, what is meant by covariance? Variation of y is explained the variation of x. That is called as covariance. Just we are going to check the variance of y based on the x variable. Similarly, covariance of